Okay, so welcome to my lecture video. So this is for sample problems from 181 to 190. So for 181, it says we wanted to calculate the probability that the person is male. So we want to find such a probability that this person is male. But this is a person under 25 years old is selected. So this is conditional probability. We want to find the probability that this male under this condition that this is less than 25 years old. Okay. So we want for this conditional probability, so we need to find the total number. Let's see. So here we want to find the total number of under 25. Then among those people, find how many number of male. Okay, we want to find those things, right? So let's say the number of people, total people, less than 25. So let's say. So they are totally we have 900. Okay, so 900. So among 900, 54% are male. So male is 54% of 900. 900 multiply 54. So we found that we have 486 male. 486 male. Okay, so then we have 414 female, right? So among this male, some are above 25, some are less than 25. So we also need to separate this into two parts. Okay, so some are above, some under. Okay, so let's say this is that they are totally insured over 25. So over 25 is 395. So we can find so under 25 is 900 minus 395, right? Okay, so we find this equal 505. So among these 505, how many are male? Okay, so among the 505, some are male, some are female. Yeah, so some are male, some are female. So we just check how many male, how many female. So this is if a female is selected from the probability she is over 25 years old is thus. So this probability is also conditional probability. Like for female, we have 47% is over 25. So here, less than is 57 is less than, right? Okay, so we can find how many female under 25 years old. So this equal, let's say, so 414 multiply 57. So this is under 25. So we know this equal 5. So among this, male equals us, right? So equal 41 minus total minus female. So we can find this. Yeah. So for this problem, we want to find probability that the claim is from red card. Okay, so here also there's a conditional probability because the conditions the picked claim from claims that exceed the deductible. So among those deductibles exceed the deductible, we want to check there's a probability, right? So this also is a conditional probability. Okay. Okay. So let's say check those exceed deductible. So we have totally like for that one we have like 300 and then multiply have the accident and also and accident is exceeds deductible 90, right? So this is from red car. And so from green car is this. We have 700 multiply this, okay, and multiply 80. So those are from green car. So those put them together. Those are all the all the claims exceed the deductible. Okay, so the probability is so totally is this, right? Okay, we can so this equal, we can multiply together. This equals 27 actually. So this equal 27, and this equal 28. Yeah. Okay, so there's probabilities 27, totally 27, 28, and among them, what is there's 20. So we find that this answer is 491. Okay. So for this one, we want to find a density function. So for density function, we need to find a cumulative function. So let's check this first, right? So this is the probability that t less than t. Okay, so then you then derivative, right? So find the density function. So this is the usual way. Okay. So this t is x squared. So x squared less than t. So here t is positive. Yeah, t is larger than 0. Okay. So here for x, we split the two parts. So here x squared, so we need to split it into two parts. So equal, let's say, x squared less than t, but this x larger than 0, plus x squared less than t, this x is less than 0. Okay, we split it in two parts. Okay, so for this part, x squared, x is positive, larger than 0, so this is x less than or equal t larger than 0, right? Okay, so plus, okay, so for this one, x squared less than x less than 0. So, okay, so this equal t. So here, so this x is less than 0, but larger than negative equal t. Okay. So when x is positive, then that's the function is negative 2x. So this probability equals this, like 0, like equal t e let's say e negative 2x dx. Okay, so plus, so when x is negative, so then the function becomes this 2 is 4x. So from negative let equal t to 0 and 2 is 4x dx. Okay, so we need to integrate them out. Yeah. So for this one, is negative 2x is just integrate out equal is negative 2x. So and then half. So this integrate out is just this half. So 1 minus e negative 2. So let equal t. Okay. So for this part, integrate out, we find this equal half 1 minus negative 4 let equal t. Okay. Okay. So then this just equal 1 minus half. Okay. Then just use derivative. Yeah. Negative 2 let equal t plus negative 4 let equal t. Okay, so we can find the density function derivative equal. So we have two parts. Like so, this one equal e negative 2t. I think e then so you can find this equal e negative 2t and half like this, like and some constant. And here negative 4 and also some constant. So constant make it. So here let's check ABCD. So we find those things density function should looks like that, right? So we check ABCD. So we find this should be answer should be A, right? Yeah. Okay. Okay, so here we want to find the probability that Paul will win the bet. So we want to check when he will win. Okay, so this is like if the two numbers differ by more than 3, George will win. So otherwise, Paul will win. So win means there are numbers like George's number and Paul's number. There is more than 3. Oh, so this equal less than 3, right? Okay. So we just want to find this probability. Okay. So what is G and P? So G is number of there just pick a number from 1 to 20. So G is number from 1 to 20, and P is also a number from 1 to 20. So let's say so here's G, so from 1 to 20, and there, and 1 to 20, and P is also 1 to 20. Okay, so this just form a like a square. Okay, so here equal, so G equal P. So we find like so then here equal the difference is 0, so difference equal 1. So we can say that G minus P equal 1, G minus P equal 2, G minus P equal 3. So let's say include 3 or do not include 3. Therefore more than 3, okay, the equal is okay, right? Okay, so we can say, so let's say, so when G equal P, so G equal P, how many is the cases? So just if G equal 1, so 1 1, just 1 1, so just like 1 1, and then 20 20. So how many cases? 20. Okay, so what is G minus P equal 1? So can be like 2 1 until 2019, right? So here have 19 ways. Okay, and then G minus P equal 2, we can find 18 ways. And G minus P equals 3, then we have 17 ways. Right? So here, so we should multiply by 2 because G minus P absolute value equal 1, right? Can be here, right? Okay, so totally is 400. G randomly G's can be 20 ways, P can be 20 ways. So how many totally this way is just that? So 20 plus 2 times 19 plus 18 plus 17. Okay. So for this problem, we need to calculate the N. So what is N? So N is, let's say we have 20 questions. So students know N question. So he know N question, and don't know, we say don't know is 20 minus N, right? Okay. Okay, so if he knows the answer, he can pick correctly. If he don't know, he just pick, he just guess the answer. So half chance, right? So here we say conditional probability is this. So what is the condition? So that he knows the answer is giving that, or the condition this. Condition this. Answer correctly. So let's check answer correctly. So we put this as a probability for case of answer correctly C. So we have two cases. If this guy knows the answer, then under this condition, answer correctly. So plus, if he don't know, then under this condition, if he don't know the answer, but he still can answer correctly. So answer correctly, there's a total condition. We have two parts, right? So this part is know the answer. This part is not don't know answer. So the question is, this conditional probability is so. Okay, so at the first, but we just put this formula. So probability for no this answer is among 20. Okay, right? So N over 20. So the probability here is 1. Yeah, and this is don't know the answer is 20 minus N. Then he can pick answer correctly is half, right? Because it's a true false question. Okay, so there's a total condition. Answer correctly. So among them, so there's a part, so we say that there's a probability. 8 to 4. This is just this probably answer correctly. So this equals this, right? Answer correctly. So among the answer correctly, what is the probability? The probability he knows the answer is this part. Okay. So this equal 0.824. So we solve for A. So by now the problem become easy, right? So here I simplify this. We just multiply 40. So this become 2n plus 20 minus n. And here's n, 2n. Yeah, multiply 40, right? So we can solve this equation. So this actually equal, we got this equation here. 2n over 20 plus n equal 8 to 4. Okay, so we can solve for a. Yeah, 2n equal 20 multiply 8 to 4 multiply 8 to 4a. Yeah, so n but anyways, here we can easily find this n, right? So for this problem, it says we want to find the probability that at least we have so many will not work, not break. Okay, so totally we have 400. So just like that, among 400, at least so many not work. Okay, just like those problems. So for each one has two cases that can work, cannot work, right? So this is binomial distribution. Binomial distribution. So here n equal 400. And we want to find this probability. So suppose x is number of not work, right? Yeah, not break. Okay, so we want to find this probability. So this x at least larger than 349. So this is binomial distribution, and because n is too big, like 400, so we should use for binomial distribution, we should use normal distribution. Yeah, so use normal approximation. So this x original from binomial, but this one we can have this. We'll close from normal distribution. So n means np, so npq. Standard deviation is npq square root, right? So what is p? So n equal 400. So then what is p? So p is probability for not work. P equal probability for not work, not break. Okay, so not break. So what is such a probability? So let's say, just say it's like to break. So required to break. This cable is this force. Suppose this is something. There's things of this force. follow normal distribution. Mean is thus, and standard deviation thus. Okay. Okay. So let's say, so this is such a pop. So this is means the force needed to break, okay, break a cable. So not break. So here, let's see. So not break under this force. So force. So here is average should be thus. So average force should be thus. So under this, not break. Okay. So if force not, let's say, if force here need this average is this break. So here need force more to break, need more force, right? Need more force. So not break. So not break means need more force. So not break. So is there's a probability, right? Okay. Yeah. So not break, yeah. So not break is need more force. Okay. So there's P is there's a probability. P equal if large than this. Okay, not so need more force to break, right? Okay, so this is a normal distribution. This F follow normal, so then we need to find this normal distribution. Okay, so we need to change this to standard normal. Okay, so Z large thing. So this minus mean divided by standard deviation sigma. So check the table, and then we find this equal 90. Okay, so we know this n will this x follow this normal. Yeah, so x follow this normal. So n is so 400. P is 90. P is 90. So this equals 360. And NPQ, we plug in the P is 90, Q is 0.1. So we find this is 6. Okay, so now the problem become like that. So we need to find the probability, like x at least 349. So equal. So we just change this to z large thing. 349 minus 360 over sigma. And so we find so use the table, and finally we find this equal 97. Okay, so there's a problem that the number of something has Poisson distributed with model at 2 and 3. So this the number n for Poisson distribution with some parameter lambda. So mod at 2 and 3. So mod is mod at mod. This model is the highest probability, right? Okay, so we have two models. So this means Pn equal 2 and Bn equal 3 are equal. So from here we can find lambda. So therefore Poisson distribution n equal k is just equal lambda k, lambda 2 of 2 factorial. So equal here equal lambda 3, 3 factorial. So is negative lambda cancel, right? Is negative lambda cancel. Okay, so from here we can solve this lambda easily. We get lambda equals 3. Okay, so now we can solve the problem. So once lambda equals 3, so we need to find the smallest number k such that the probability more than this is 25%. So less than this is 75%, right? So we just want to find this n equals 0 or 1 or 2 or then we find the k, add them up such that this should be at most is 75. So we just check this. So lambda equals n equals 0. N equals 0 just is negative 3. Okay, so here 1 plus, so just this is 3 over 1 plus 3 square over 2 plus the 3 over 3 factorial. So we just check until which number this will be less than 75. Okay. So just to do some calculation, yeah. Okay. Okay. So for this problem, we have two dice. So one is red one and green one. So we have two red one or green one. Okay. So red one is can be 1 to 6, green one 1 to 6. Yeah. So what is the question? So we want to find the probability. So giving that, so this means the conditional probability. So we just check this condition, giving that the number that is shown on the red die is larger than the number in the green die. So we just say here G and this green. So the condition is thus, right? Okay, so we just check if R equals 6, so then green can be 5, 4, 3, 2, 1, right? Okay, and so if this R is 5, so then here can be 4, 3, 2, 1, and if this is 4, so then this can be 3, 2, 1, and if this is 3, then 2, 1, right? And so we just check all the cases. If this is 2, then 1, right? So those are all the cases. Okay, so totally how many cases? So we say this is 1 plus 2 plus 3 plus 4 plus 5 equal 15. Yeah. So totally we have 15 cases. So among those 15 cases, how many satisfy this? Like the sum is odd number. So we just check how many cases, right? So here is okay, so 1 case. Here like here 1 and here 1, right? On the 3 2. Yeah. So here add them up is odd. So here we have 2, right? Yeah. So here we should have 3. No, maybe not, also 2. Yeah. So yeah, 2. Like that. So if there's odd, then just find it even, right? So here this is even, so we just pick odd number 3. So totally 1 plus 1 plus 2 plus 2 plus 3, right? Okay, so for those one we have 2 normal distributions. So like in 1982, her mother's score is 93th percentile. Okay, and so this let's say, so this score we put this as x. Follow this normal distribution, mean is 503, and variance, the standard deviation is this. Okay, so let's say, so for this x, the mean is this, like 5 or average 503. Okay, so AB's mother's score is here, so such that this is 93%. Okay, so here's the mother's score is the 93 percentile. 93 percentile. Okay, so this year, in 2008, this is also normal, but average become 5 to 1. So graph just like that, right? So here average here. Here. So here's 521, and the dot AB got the same numeric score. So score is the same, like here. So it's the same score. Okay, so we want to find this her percentile. Okay, so we understand the question. All right, so at first we need to find this cutoff point. Suppose this is A. Okay, we want to find this A. So this A is 93 percentile. So we find this A. So this is just, let us say, x less than this A is 93 or 93.00. So what is A? So we changing this to standard normal. So this becomes Z less than A minus mu, so 503 over standard deviation. Standard deviation is 9604. Okay, so this equal 9300. So we can check the normal table, find the normal from the table we can find the cutoff point, then find A. So finally we get A equals 646. Okay. So now the problem become easy, right? The percentile is y less than 646. So equal, so we change to standard normal, then check a table. So this become 646 minus, so mean is this, and the standard deviation variance is this. Standard deviation is this. Okay, so just want to find this probability. So by checking table, so after some calculations, so we find this probability is 89. Okay. So here we have, so let's say, so this lifetime or useful life, so those things follow normally distributed with mean thus and standard deviation thus 3. So we say lifetime, we put this x. This lifetime follow this normal distribution, mean is 10 and standard deviation 3. Okay. Okay, so what we want to find? We want to find the probability that the total useful life of 2 refrigerators will exceed 1.9. So we pick 3 of them. So here we say x1, x2, x3. We just pick this 3, and all those follow same distribution, right? So what we need, we want to find such a probability. So the x1 plus x2, the total lifetime is larger than 1.9 of x3. We want to find this probability. Okay, so we just change this as this. x1 plus x2 minus 1.9 x3 larger than 0. We want to find this probability. Okay, so we just let this as z. Z equal x1 plus x2 minus 1.9 x3. So what is the distribution for z? So we say normal plus normal, normal minus normal is still normal. So for this one, this z will follow normal distribution. So what is the mean for this? So mean or mu z. So mu equal, we say z, right? So expect this equal just the x1, which is 10 plus 10 minus 1.9 times 10. So this equal 1. So mean is 1. And standard deviation or variance. So we say sigma square or Vz. Vz equal Vx1. So this just like that. Vx1 plus Vx2. But here is plus a negative 1 square, negative 1.9 square Vx3. So Vx1, so standard deviation 3, so Vx1 is 3 square, 9 plus 9 plus 1.9 square times 9. Okay. So variance equals us. So, and we can find, so take square root, the sigma is 7.1, take square root. Okay, so we know this z follows such a normal distribution. Mean is 1, standard deviation 7.1. So what we want to find is this probability, right? Larger than 0. So for this probability, we are changing to standard normal. We still use this. We should use different letters. Still use this there. So this minus mu divided by sigma. So, this probability. Okay. So from the check table, so this equal negative something like so. Do some calculation, but anyway, so we can find this probability is such. Okay, so those are problems from 181 to 190. So we can stop here, and thank you for watching.